Alright, this section's over exponential functions and equations, and this particular function here is, of course, an exponential function because the variable is up in the exponent. I've got something written over here. This is just to kind of remind you that a number raised to the 0 power is equal to 1. So I thought I would just throw that in there. But in the previous section we talked about inverse functions, and so in the next section we're going to talk about how do you find the inverse of this function. How do we find the inverse of a function whose exponent is or whose variable is up in the exponent? But first we're going to just graph these. And of course, when we learn how to graph, we just kind of do a table here. Now I'm going to start with 0 and then 1 and 2, and so this is going to be my x, and then this will be 2 to the x column over here. So when we plug 0 in up here, 2 to the 0, we get 1, and then 2 to the first power we get 2, and 2 to the second power, right, we're taking this 2 and plugging it over here, we get 4. So we call this exponential growth. Right, this is sometimes known as exponential growth. The function is increasing exponentially, so you might hear that also. Right, and so we can go on and on forever like that. And of course, if we had to graph this thing out, we would start with, let's change colors here. We would start with plugging 0 in, we get 1. Right, and we'll say that this is 1, 2, and we'll do 3, even though it's not written right there. We plugged 1 in and we got 2 out. Okay, plugging 2 in, we get 4 out, and then plugging 3 in, 2 to the third is 2 times 2 is 4 times 2 is 8. So anyways, so we get something like, we get a graph that looks something like that. And actually I do have these graphed out. Okay, so let's just actually go take a look at what this graph looks like. So as you can see here, this is the graph. Of course, I plotted this point here, and then this point. Let's see, this is 1, 2, 3, 4. Yeah, plotted this point, and then this point here, and then so on. Okay, and yes, it does have. We can plug negative numbers into this and get this part of the graph also. All right. Okay, so we graphed. I declare the board there. F of x is equal to 2 raised to the x. Alright, what happens when this number is between 0 and 1? For example, we'll call this g of x, give it a different name, and we'll say a half raised to the x power. Well, this can actually be rewritten as 1 to the x over 2 to the x. Okay, this is still an exponential function here. 1 raised to the x is just 1. So no matter what you plug in for x here, okay, you're going to always get 1 out. And then this is 2 to the x. So what happens when x gets larger and larger? For example, if we do a table here, so this is my x's, and this is 1 over 2 to the x goes here. So if I were to plug, for example, 0 into this, 2 to the 0 is 1. So 1 over 2 to the 0, you would have 1 over 1, which is just 1. And then if I were to plug 1 in, you'd have 1 over 2 to the 1, which then becomes a half. So you see what's happening? The number's getting smaller and smaller. And if we plugged a 2 in, we'd have 2, and we get 1/4. So if we take a look at this, what's actually happening here is the graph is going to be decreasing like this. Okay, it's going to be decreasing, and of course, as x gets larger and larger and larger, it will never really approach 0 unless you're considering going to infinity, but that's calculus class, and I'll leave that for calculus. So when we're talking about limits. But anyway, but it gets closer and closer to the x-axis as x gets larger and larger going outward. So let's take a look at that graph. Okay, so this was 2 to the raised to the x, and this red line right here is a half raised to the x. So we can see that it's getting closer and closer as x gets larger and larger. And look, there's some